I've noticed that one person that can eat practically ghost pepper and not feel the heat. I unfortunately am not one of those people. I can barely eat a bell pepper without feeling the heat even though there's no visible spice. This is because of our genetic makeup. There's a gene that actually controls for taste and spice. There are people known as non-tasters, tasters, and people that are in between, also known as people that are heterozygous. Tasters, or super tasters, have 2 dominant copies of the allele. Non-tasters have 2 recessive, and then we also have heterozygous, which is a mix of both. 1A and 1 lower. In order to determine which one you have based on your genetics, there's actually a test. There's 3 different components to this test. The 3 steps are as follows: polymerase chain reaction, restriction enzymes, and DNA electrophoresis. The first step in this is polymerase chain reaction. First, you take an ordinary DNA double helix from a sample that you collect. Then you heat it up. This causes the hydrogen bonds in the sample to break. Then you cool back down and add in an enzyme and a primer in order to create a whole new set of DNA molecules. You have 2 new strands from 1. You repeat this process about 34 times in order to get the amount of DNA you need to work with for the restriction enzymes. Investing can be used as an analogy for PCR. You invest a certain amount of money and then you get exponentially more back. This is the actual machine that completes the process of PCR. The second step in this process are the restriction enzymes. The specific restriction enzyme that we want with this mutation is HEY3. HEY3 creates what's called a blunt cut, and it cuts between the G and the C in the GGCC line. If the person is a taster, they will have this mutation. Restriction enzymes are where you decide to put your money after it was invested. The third and final step in this process is DNA electrophoresis. There are 5 wells in our gel. The first well is the control, like any good experiment should have. The second well is person number 1's undigested DNA. The third well is person number 1's digested DNA. Fourth well is person number 2 undigested, and fifth well is person number 2 digested. The longer the DNA is, the less it's going to move down because it has lesser possibility of moving through the very small holes within the gel. It's pulled towards the positive because DNA has a negative backbone and it's repelled against the negative. So, from that information, we are able to conclude that person number 1 is a super taster because of where the bands are, and that person number 2 is a non-taster. If, for say, person number 1 had a band right here, that means that they would be heterozygous for the gene. Gel electrophoresis can be compared to the money that you earned and how it was spent. And this is what your gel should look like after you have finished the process. Thanks for watching!